Hey everyone, and welcome to today's live session on TCS Digital by Quant Masters. In the last session, that is yesterday's session that we had at 9:30, we were going through this particular problem called LAPINDROME, and we're going to continue from there and go through a little bit more about it. So, before we go to the session, hi to everyone, and very glad to see that a lot of you guys are joining in. So, this will be our live session for 8th of July 2021 at 9:30 p.m. Again, these are free set of series that you guys can access. So, let's go ahead and hopefully make the best use of these series. Now, in the last session, if you haven't gone through it, if this is the first video you're watching, I would suggest you to please go through the previous video and give it a check, because this video is a continuation of the previous video where we had done anagrams problem in C++. Now, the problem was something like this. Let me just explain that very, very quickly so that all of us are in the same frame of understanding towards the problem. So the interview question is to figure out if an input string is lapindrome. Now, what exactly is lapindrome? Like, we know what is a palindrome. We know that. We understand that. But what is a lapindrome on the other hand? See, it's slightly different than palindrome. As we know, a palindrome is where you have something like race car, where first half of the string is a mirror image of the second half of the string. Whereas in a lapindrome, first half of the string must have same characters as second half of the string, and it can be in any order. It should be same characters but in any order. So that's exactly what we are trying to figure out. So for us to do this, we are first going through the problem, that is to find out if two strings are anagrams, because the entire concept of lapindrome is built, or in other words, based on the concept of anagrams. So what exactly are anagrams? If you may ask, anagrams are just two strings which have same, let's say, exact same number of characters, but these characters are in different orders. So as we have taken a couple of examples, let me quickly go through them. Let's say, for example, heart and earth. Both of these strings have the same characters, but they're in different order. So these are called anagrams. Now, we have also seen in the last session how to find if two strings are anagrams in the best time complexity. That is to create an array of 26 characters, like 0, 1, 2, 3, and so on up to 25. And each index in the array, like index A indicates, index 0 indicates frequency of character A, index 1 indicates frequency of character B, 2 indicates C, and so on up to 25 indicating the count or frequency of the character Z. So what we are doing here is, for the first string, we go through each character index wherever we have them and we increase the count. For the second string, we go through each character index wherever they are and we decrease the count. So when we do this for first string and second string, that is increase and decrease the count, in the end, if we get 0 everywhere, we can say that they are anagrams. That was our entire logic. Now, we have to modify this program slightly, because in the previous program so far, we had two strings. We had two strings as input and we used to find out whether they are anagrams. But in this scenario, we're only gonna get one string. If it is something like ZAAP and PAZA, this is going to be a single string, and this string we're going to have to take in such a way that we're going to have to somehow split it by half and say that first half and second half should be anagrams. Now, what if there are odd number of characters like A, B, C, D, C, B, A? Then we can ignore the middle character. It really doesn't make sense for us, and this is how we can solve it. Now, the logic seems very simple to what we have done. So let's take a look at this. And we need to take a look at both test cases, because in reality, if we solve it only for one test case, what if we cannot for the other test case? That is, what if we solve it for odd number of characters, but we don't solve it for even number of characters. We need to identify both scenarios. So let's take a look at how we're going to do this. So one way is if I have something like ZAAP and PAZ or ZA, one logic that we can think of. Now, what do you guys think of? Before I give you the logic, let's ask all of you in the live chat that are here. Let's ask all of you as well. What do you think would be the right way or the right logic to work through this, or the right method to go through this, so that we can figure out that this string is, let's say, a lapindrome? So we may say, you know what? It sounds like a simple logic. We're going to split it into two strings. Anyway, we have anagram program. Anyway, we are sending two strings. So what we're going to do is, let us split the string into two strings, and we're going to call this as string 1, and we're going to call this as string 2. And let's send these two strings over to the function. We can do that. But I don't even want to create two more strings. I don't even want to split them into two more strings. I want to send this exact string itself to the function. Let's say in interview, assume, forget about splitting into two strings. If it is asked in such a way that this time let's just change this code where we are only reading one string. I'm going to change this one string. Now instead of anagrams, let's change it to lapindromes of just one string. So if it is a lapindrome, we're going to print its lapindrome. Otherwise, we're going to print, sorry guys, I think I've closed the document, unfortunately. Let me just open it again. All right, perfect. Otherwise, we're just going to print not lapindrome. Sounds like a simple logic. Now, one of you have stated we're going to do string slicing. Absolutely right. We're going to do slicing of the string in this, because I don't want to create two separate strings. So perfect logic. What we're going to do here is figure out which index our first string starts from and how long we should go ahead, and which index should our second string start from and how long should we go ahead. This is what we're going to figure out, and we're going to solve accordingly. So let's try this out. Now we're only sending one string. Why am I doing this? Imagine in your interview, you have this function lapindrome where you are given the condition that you only need to fill this function. The rest are not there. You only need to fill this particular function. So there's only going to be one function, lapindrome. You need to fill this function. The rest you can't edit. So if such a question is asked, we need to fill this function when only one string is given. I have one question. Yesterday you said that you'll be modifying a third array. See, this is the final array that we have. All right. So this array, we are just using it to indicate whether we have, let's assume, our entire two strings which are anagram or not. So I just gave that as an assignment. Like I'll give you the assignment question again. That is something I wanted you guys to figure out, because it's a simple enough logic. The logic pretty much, the question pretty much was to use three strings and figure out if they are anagrams or not. How are you going to figure that out? To do this, you're going to have to take first two strings. If there are three strings, take first two strings and figure out if they are anagrams. If they are anagrams, the result will be 0. Right? After result is 0, then take second and third string with the same array. Now, entire array values are going to be 0 anyway. So to the same array, you can take second and third string and figure them out. So you just have to call anagram function twice. If you really want to go through it, we can just quickly observe this once here. So all that you need to do is call anagram function twice by sending string 1 and string 2 first. This will ensure that string 1 and string 2 are anagrams. Then you have to call anagram function once more by sending string 2 and string 3 here. That's it. You just have to call the function twice. I hope the logic is simple and easy. Now, let's go ahead and try to solve this particular program. I have got a few different answers. Can we solve it by C? We'd prefer C++ because when we go further on within more and more programs, more and more programs in TCS Digital, we're gonna have to entirely go through, let's say, something like a lot of different sort of data structures. And if it is just C, we're going to have to implement our own data structures, which is going to take a lot of time and effort. Instead, we can use C++ to avoid implementation of data structures and directly use them. So let's go ahead. Now, in this scenario, let's take this example. Now, there are going to be two test cases as we discussed. One is a test case where our string has even length. Another is a test case where our string has odd length. Let's take both. I'll take ZAAP and then PAZA. I'll also change this so that they look similar. I'll just take this as indices 0, 1, 2, 3, 4, 5, 6, and 7. Let's say this is our string. Now let's take one more scenario. I'll take only 0, 1, 2, 3, 4, 5, and 6. We're going to take an odd character. So I'm just going to do this. A, B, C, D, C, B, A. So now it sounds like a simple thing. Now the idea here is when it is even and odd, either way I need to divide it by 2, right? I need to find the length and I need to divide by 2 so that I can get to know which is the halfway point. So when I calculate length, now remember, we are storing them as string. That means we can use length function directly. We don't have to call string length separately and send the string because ours is an object of string class and we can use length function directly. So if I use str.length here, the value I'll get is 8. When I do 8 by 2, I'm going to get 4. So this particular value, whatever is there, n by 2 that I get, length, which I get as 4, I can immediately assume from 4, please note this, from 4, I'm supposed to get my second string, and till 4, I'm supposed to get my first string. This is how I can figure out. So I can immediately say my first string starts from 0 till less than 4. My second string starts from 4 till end of string. That's our entire logic. So same way, if we look at the other case, if we look at the odd scenario, if I use string.length, we're going to get number of characters or 7. 7 by 2, we'll get it as 3. Now, in this case, observe, since the length was odd, we basically got it as 3.5. But since we are storing it as integer, we get to store it as 3. Now, in that case, index 3 is supposed to be our midpoint. So what am I supposed to do? When it is even, I'm taking 0 to this mid value minus 1. Here, if I take 0 to mid value minus 1 as my first string, I cannot take from mid to the end for the second string. I need to take mid plus 1 because the middle string doesn't matter. It really makes no difference over here. So we need to look at these two separate conditions. That is, if the length is even or if the length is odd. So once we look at the condition that if the length is even or odd, we're gonna take the same scenario and we're gonna see if these are anagrams. Same logic as ours, but we're just gonna make some slight changes. That's it. And then we'll see if we can improve our code, if we can make it better as well. We'll see how to do that. So let's take this. So first we need to figure out if the length is even or odd. Because if the length is even, I'm going to have to go through a slightly different logic. If the length is odd, I'm going to have to go through a slightly different logic as well. So we're going to have to create a flag for it. So what we're going to do here is remove all this function content. We're just going to rewrite it. All right, not to worry. So first thing, if str.length is equal to 0, our first test case, that means it's not a LAPINDROME whatsoever. We're just going to return 0. No point in checking anything. Now, if string.length is 1, then I don't even have to compare. I don't even have to worry about it. Because when length is 1, I cannot split it by half and say like, you know what, I have first half of the string and second half of the string. So when length is 1, we are doing nothing. We can't split it to two separate strings. So when length is 1, I'll immediately return 1. stating that it is a lapindrome. So these are the two initial test cases that we need to work with. Again, just to remember, how do we get to work with test cases? We just need to remember all the different scenarios, all the different kind of inputs that you can expect, and then figure out what could be the output accordingly. That's basically all that we need to do. So let's go ahead here and give this a check. Let's go ahead here and give it a check. If our couple of strings here are lapping, or if a single string, not couple of strings, if a single string here is lapindrome or not. So first thing, we need to find the length of the string. So I'll take int n equals string dot length. Now anyway, we are calculating length possibly multiple times here. If the length is more than one, it gets calculated here, then here, then here. So to avoid all of this, you can just write it here. This. Now, on the other hand, you can also see if string length is 0, we are returning 0. If string length is 1, we are returning 1. To change this, I can say if n is 0 or n is 1, we'll just return n. Now, how does this make sense? Let's take a look. If n is 0, there are no characters, so we are returning 0. If n is 1, there's only one character, so it's a lapindrome. Whether you read it from left to right, right to left, it's a lapindrome, we're returning 1. So we can combine this into a single condition as well. We don't have to put that in separate conditions. So this is how we can make, let's say, little changes. And these little changes do matter because there'll be tens and tens and thousands of students who are going through the same program, and if yours even executes slightly faster than another person's program, and your program goes through all the test cases in the shortest time possible, isn't that a better logic? Of course it is. So that's exactly what we're going to do. We're going to create our simple logic here and we're going to improve it. Now I'll tell you guys why I'm not going directly to the optimal solution. The reason I'm not going to the optimal solution directly is, see, we can't always figure out the optimal solution immediately. We sometimes figure out a general solution and try to convert it to optimal solution. So that's exactly what we're going to do here. Now, in this case, the length of the string is more than 1. Since the length of the string is more than 1, I need to figure out if it is even or if it is odd. Remember, if it is even, I need to take 0 to n minus 1 as my first string and n to my final character as my second string. If it is odd, I need to take 0 to, again, n minus 1 as my first string, but instead of n, I need to take from n plus 1 to end of the string as my second string. So I have two different scenarios, that is if n mod 2 is equal to 0, if let's say string is even length, string is of even length, or else that is in case string is not of even length. We need to do different scenarios. So let's write this code. Let's write this simple easy code and then we're going to try to improve it. So again, just to point out, we're not creating the perfect code right away. We're trying to create a code which works and then trying to make it better. Now let's take a think about this. What is the first thing that we're gonna do? Like if the string is of even length, what are we exactly gonna do? Any guesses? Let's think through. If the length is even, how am I supposed to divide it? What am I supposed to do? The length is even. So what exactly am I supposed to do? Again, I shouldn't split the string. I shouldn't split it into two separate strings. I should somehow figure out some way so that we don't struggle in the case of creating extra memory. So here's the entire logic. Here's the basic and simple logic. So thanks a lot for one of you studying. That's very informative. Very glad to hear that. So let's go ahead here. This is going to be our first string. If it is even, our first string is going to be from 0 to n by 2 minus 1. Our first string will be from 0 to n by 2 minus 1. And our second string will be from n by 2 to length. Now, on the other hand, our first string will be 0 to n by 2 minus 1. and the second string will be from n by 2 plus 1 to length. Now we're going to figure out how to avoid these changes later on, because there are certain functions. There are certain functions like ceiling which we can use. For those who may not know, see, I can combine both scenarios together. I don't have to use two separate conditions, because let's remember, I just want everybody to clearly know this. If n is 8, this will be n by 2. Alright. So when it is even, I'm going to take 0 to n by 2 minus 1 and n by 2 to end of string. Now in this case, n by 2 is supposed to be 3.5. Instead of 3.5, what if I am converting it to its ceiling number? What if I can somehow find a way to convert it to 4? Then I don't need two separate scenarios. If you guys think about it, if I can convert it to ceiling, then I don't need separate values. But then again, I need to compare with the previous value. So there's going to be different scenarios whatsoever. So let's think about it over time. That's something for us to ponder about. For now, let's start with the code without any delay. As many of you stated, divide at the center, compare by 2. We're going to divide it by 2. Absolutely right. As Swami, one of you pointed out, floor division happens only in Python. We don't have it in C++, but we will do that in Python over time. So let's take a look at this. So if our string is even in length, so my first string will go from I equals for int I equals 0, I less than, remember, less than n by 2. N by 2 index should not be a part of it. So I equals 0, I less than n by 2, and we're going to increase I one at a time. So let's do this. I equals 0, I less than n by 2, I plus plus. Now for each of the character available in this end. Now one more thing, we haven't created our array. If you go back to our previous session, we had a particular array here. There is an integer array of 26, which is full of zeros. Alright, so in this array, what we're supposed to do is, for the first half of the string, until we reach n by 2, that is until we reach 4, as long as we are less than that, we're going to increase the count. So we're going to say array of string of I minus 97. That's how we get the index. If you remember, array of I is z. So z index will be, ASCII value will be 122. 122 minus 97 gives us the value that is going to be 0. Gives us the value that's going to be 25, the index in which the value here is 0. So that's what we are supposed to update. That is the frequency of z. So that's how we are saying array of string of I minus 97. We are increasing it. If this statement was a little confusing to you, do not worry. You can go through our previous video if you haven't gone through it later on, so that you can understand how exactly the same is worked through. Now, on the other hand, I need to use one more for loop. This for loop again will be, let's take int I equals this time n by 2. Because it's even, I can start exactly at n by 2, which is 4. And I need to continue until where? Until the length of the string. So where have we stored length of the string? We have stored it at n, which is 8. So I can say here, for I equals, I have one question, same operation for both even and odd length functions we can use. Yes, we're going to do that one step at a time. Absolutely, yes, you're right. We can use the same for loops for even and odd, but we're going to do that over time, one step at a time. All right. So very glad to hear that it's easy to understand by Varun as well. Very glad to hear that. So let's take this scenario. I equals n by 2. I less than n, because remember n is 8, we have to go till index 7, and we're just going to increase I, and here all that we're going to do here is array of string of I minus 97. Instead of increasing, we are going to decrease it. That's it. This is the entire logic. Once we have done this, we are done with this entire code. That's our whole logic done. Now, on the other hand, if it is odd, let's see what we need to do. If it is odd, do we need to change anything? Let's take a look at it. If it is odd, n by 2 I get it as 3. Should I continue ahead till 3 or should I continue ahead only till 2? Let's skip one of them. Middle anyway is common for both, so why consider it? Let's skip it entirely. So if we skip it, I need to take from 0 to 2. That is 0 to n by 2 minus 1. And then from n by 2 plus 1, I need to go till length of the string. So here, I need to go till n by 2 minus 1. How will I go till n by 2 minus 1? Again, less than n by 2. I less than n by 2. But in the second scenario, I shouldn't start from n by 2. I should start from n by 2 plus 1. I should start from here. So I'm going to start from n by 2 plus 1. That's what we're doing here. So at Mukesh's question, this is a lapindrome where first half of the string has the same characters in the second half of the string. First half of the string has same characters in second half of the string, but it could be in any order. So it could be a palindrome, it couldn't be a palindrome, both can happen. But just remember, first half of the string should have same set of characters in any order in the second half of the string as well. So I have one question, why decreasing? Can you let me know where why decreasing? Because I can answer your question. To the question why decreasing, if you can let me know where, which line number. I hope you can see the line number on the left, and you can let me know at which line number you find it. You're asking why exactly we are decreasing something, so I can go ahead and help out to answer the same. So by the time, let me just point out, this is if string is even, we're supposed to take half the string here and half the string to the next case. So I have one question he's asking in the second string, n by 2 to n, why do we need to decrease? No problems, I'll just give you a simple logic here. Take this scenario. This is our string. Now, if this is our string, can I say when I divide it by half, it's going to become like this? This is going to be first half of the string. This is going to be second half of the string. Now, what is the question? We need to figure out if first half of the string is an anagram of second half of the string. If first half and second half are anagrams, then our logic is right. How will I get to know if two strings are anagrams? For one string, I'm going to increase the count of characters. For other string, I'm going to decrease the count of characters. That's exactly what we're doing here. For one string, I'm going to go, this is going to be my first string because we are dividing into half, right? When we divide it into half, virtually we'll consider this as our string 1 and virtually we'll consider this as our string 2. For our string 1, we're going to go from one character at a time. At Z, whatever we have, we're going to increase that count by 1. We'll go to A, increase that count again by 1. We're going to go again to A, increase that count again by 1. We're going to go again to P, wherever it could be. I'll just change this to something we can observe. I'll just use C. We'll just go to C. I'm going to increase the count again by 1. So after the first half of the string is done, for the second half of the string, I need to go to the same characters and decrease the count. For C, I'm going to decrease it by 1. For A, since I have it, sorry, here A we have had twice, I did not observe that. So we'll increase it to 2. For here, since we have A twice, once we traverse through it, it's going to decrease to 0. Z we have once, so we go through Z, we're going to decrease it again to 0. So when the entire integer array is full of zeros, we can get to know that our entire, let's say, integer array over here is full of zeros. That means our strings here are anagrams, which means our entire string is a lapindrome. That's our whole idea. I hope that's simple and easy to work with. So that's exactly what we are doing here in line 23 as well as line 16. We are decreasing it for that particular reason. Right, I hope that's clear and easy to understand. So both same thing. So what we are doing here in line 16 is that if that string is even, please remember, this is if the string is even. If string is even, what are you going to do? You're going to take first half entirely and second half entirely. If string is odd, what are you going to do? You're going to skip the middle character, right? You're only going to take this much and then this much. That's why I've written two different scenarios. If string is odd, I'm going to take till n by 2, but I'll skip the middle character when decreasing. Here, I'm not going to skip the middle character. That's the only difference. All right, I hope that's very, very clear. Now, with this done, all that we need to do here at the end is figure out if our array is full of zeros. So we're going to go through one more for loop for int I equals 0, I let's say less than 26, I plus plus. We're just going to check if array of I is not equal to 0 at any point of time. If it is not 0, we're going to return 0, indicating that it's not a not a lapindrome. Otherwise, we're going to return 1, indicating that it is a lapindrome. This is exactly what we're doing. So let's try seeing what exactly happens here. Let's try compiling this out. So we'll just compile it. Let's see if we get any errors. None. That's a good sign. So let's execute this. I'm going to give something like A, B, C, D, E, D, C, B, A. Now, it's also a palindrome. I'll give something else, CADB. Now, this is a lapindrome because left half of the string has the same characters as right half of the string, and we can easily work through it. So it says it's a lapindrome. Let's try even characters as well. I'll give ABCD, DACB. This will also be a lapindrome. Let's give only one character. This is again a test case scenario, right? If only A is given, that's also lapindrome. But if something like AB is given, it's not lapindrome. So this is how we get to know and figure out if our program works through every, let's say, test case or not. So this is your simple program to find out if a string is lapindrome. Now, let me ask all of you. I have one question before I go ahead. What is the use of declaring I in for loop and declaring outside? What's the difference? In this case, there's really not much difference. If you're using only once, you can declare in for loop. But since we are using multiple times, it's always a better thing to declare outside the for loop, because once you declare it multiple times, you're allocating memory and deallocating memory for it multiple times. That may take very slightly, very slightly, a little more amount of time. So to avoid it, you can just use the same thing declared once. So this can also be done. So all of these are little things that we need to go through, that we need to think through. Now, here's what I'm going to ask to all the students who are joining in. In this case, I have one question. It still does not work for cases which are upper and lower case. It will always give not palindrome. Yes, we'll solve that. Don't worry. We'll solve the upper and lower case up next. We'll add that condition as well. Since one of you have asked for it, we'll even add that condition. It's a very easy condition to add. But before that, let's somehow try to figure out to see if we can make this code slightly better. If we can make this particular code slightly more better. Now, is the first two lines in if and else same for us? It's basically the same. There's absolutely no difference. The first two lines we have are the same. So I can remove them from if and else and I can put it before them, because for whether we are going through if condition or else condition, the first for loop is basically the same. So I can delete it from here, I can delete it from here and paste it right here. So this makes perfect sense. But for the second for loop, it's not the same. Because if you observe here, this is I equals n by 2, this is I equals n by 2 plus 1. So let's take a look at this very quickly and see where exactly we are going wrong, what exactly is happening here. Now, just remember this. I want all of you to please kindly observe and remember this, because this is going to help us out how to solve this very well. So here, in these scenarios, please note this very carefully. Again, any questions, any doubts, you guys can put it in, let's say, the live chat. I will help through, but please go through this very clearly, because we're going to get rid of these conditions. So this is in case it is even. This is in case it is odd. So if you observe, in case it is even, if n is something like 8, n by 2 will be 4. In case it is odd, if n is something like, let's say, 7, n by 2 will be, technically, if you calculate it, 3.5. This is going to be our scenario, right? N by 2 will be 3.5. Now, how can I take this scenario and put it in the same case? Because when it is 3.5, I need to go to 4. When it is 4, I should stay at 4. So can I apply ceiling function in both of these? Can we do that? Can we apply ceiling function in both of these? Because in both case, second string is supposed to start from index 4. That's what we got to know. Here also it starts from 4. Here also it starts from 4. Since it starts from 4 itself in both case, if I take ceiling of 4, it's going to become 4 itself. If I take ceiling of 3.5, that's also going to become 4. So can I do that? What do you guys think? Can we use ceiling function over here? This is what I want you guys to think through. Let's take a guess and think through. And you guys can let me know if we can use this particular scenario. Of course we can. So what we need to do is create the ceiling first. We need to create the ceiling value first. And once we create the ceiling value, then we're going to have to, let's say, utilize the same thing. So there's an easy way to round up for those who may not know. Please note this. For those who may not know, there's an easy way to perform a round up within. I have one question. Is ceiling available in C? Yes. Function C. We have a function called CEIL. All right, and we have a function called floor. What happens is whenever you give a double value in this, if you give 3.5 in both cases, floor will take the lower integer value. Ceiling will take the upper integer value. That is, it's going to convert it to 4. Even if it is 3.1, it's going to convert it to 4. So that's the difference between ceiling and floor. So as we see this in number line, that's the same logic. So instead of using ceiling function, if you really don't want to do that, you can even use modulus, you can even use other operations. That's completely up to us. There's a lot of different operations. I'm going to give you guys a simple logic if you don't want to use ceiling function. Think of this. N by 2, I'll call it as some variable called mid. Mid is equal to, here's what I'm going to do. N plus 2 minus 1 divided by 2. Now, let's observe this. Let's see what exactly happens here. If we observe this in this scenario, what is n plus, in this case, 4. 4 plus 2 will be 6. 6 minus 1 will be 5. So I'm going to get this as, sorry, n is 8. Very sorry, guys. This is n by 2. I'm supposed to take this. N is 8. So in this scenario, what is 8 plus 2? 10. 10 minus 1 will be 9. What is 9 by 2? 9 by 2, I'm going to get 4.5, which is going to be stored as 4 here. That's how I'll get n by 2 as 4. Similarly, I can take this scenario here for odd. For odd, n is 7. What do we get? 7 plus 2 is 9. 9 minus 1 is 8. So 8 by 2, I'm going to get 4 again. So I can get mid value using this formula. I don't even need to use ceiling function. I don't need to use ceiling function to get something else like double, then back to this value and everything. So these little methods help you avoid these values as well. So 4.5 will become 4 because we are storing it in integer, and 4 becomes 4 exactly as we are storing it in integer. So we can use this formula and we can start this from mid, because here if you observe, when I use mid formula, I'll get 4 even here, I'll get 4 even here. Sounds perfect, right? So glad that it's very clear at Varun's question. Very glad that you guys are able to find this easy. Again, if you find it a little difficult, the video is available here. You can pause it, watch it, trace it at the same time. You can do all of these to work through. So that's always there for you guys as an option. So what we're going to do here is create one more variable here called mid. So let's do this. Mid equals the formula that we have, that is n plus 2 minus 1 by 2, or in other words, just make it as n plus, I have one question. Yes, you can just make it as n plus 1 itself directly. Absolutely right, because we are always dividing by 2 itself. Perfect logic. So I can take it as n plus 1 by 2. This will always give us our ceiling, so we don't have to do ceiling function, divide and then convert back to integer. All those steps are avoided here, right? So that's what we are doing here. So in this case, I will take this as I equals mid, and here also I'll take it as I equals mid. That's it. Now since the logic is same for if and else, I can take it out of if and else and paste it outside. So this will ensure that we don't need this two separate conditions. That's it. So this, remember, is if string is of length 0 or 1, and this scenario is get mid value of even string and mid plus 1 value for odd string. This is exactly what we're doing. Once we do this, let's go on for the next scenario. So we go through first half of the string, increase array or increase frequency count or increase frequency for first half of string. Similarly, decrease frequency for second half of string. That's it. Then check at the end. Check if array is full of zeros. That means it's a LAPINDROME. So this is your entire program. Now, let me ask you guys one more question. Let me see if we can make this even better. Now, can I combine these two for loops together? Let me ask you guys this question. How many times does the first for loop execute? Let's take this scenario. If the string is even, let's take the length as 8. First for loop will execute 4 times, second for loop will execute 4 times. If the string is odd, let's say 7, first for loop will execute 3 times, second for loop will also execute 3 times. So I can say both of these execute same amount of times, right? Since both of them execute same number of times, can I combine them? This is my question. This is my next thought. Again, why are we doing all of this? To ensure that our program is as time efficient as possible. Having two for loops which go through same length is worse than having one for loop which goes through same length. Now, don't get confused. Please don't get confused. I can have one for loop within which I have two statements, or I can have two for loops within which I have two statements. Here what happens? This for loop goes through entire scenario once, like each time the variable increases and so on. Here also each time it increases. So you have big of n by 2 here plus big of n by 2. That means big O of n. Your time complexity is big of n. Now, in this scenario, if we combine it, we are able to find this LAPINDROME in big O of n by 2 itself. Isn't that better? So our entire logic is just big of n by 2 plus 26. Within this constant value, we can get to know if our entire string is LAPINDROME or not. So let's try to figure out how to do this. Now, before this, whatever change we have done, I just want to show you that this works. I just want to show you that this particular example does work. So let's compile this, run this. I'll take this is a LAPINDROME. I'll take sorry guys. I'll take again one more scenario. We'll take something like let's say this is also a LAPINDROME. So our logic works. We'll also try one not LAPINDROME. This is not a LAPINDROME. This is also not a LAPINDROME. So program works perfectly. Now we're gonna combine these two for loops together. Now for that purpose, we need two separate iterators. I cannot use I for both because I here represents index 0, I here represents some other index. So I need two separate variables. So I can take I equals 0 and j equals mid. And the condition I less than n by 2 and j less than n. And then I plus plus and j plus plus. I can use these two values. So comma operator is something which we can use to ensure that we can perform multiple operations together. So once this is done, let's take both of these statements, put this in here. Let's see how exactly this works. So let's try this out. Let's compile this. Sorry guys, we have not okay, we have not declared j first. Let's do that as well. Okay, now that this is done, let's try compiling this. And I have one question. Can we use two conditions in one for loop? Absolutely. The scenario is you can use two conditions in one for loop. Only the last condition matters. So it doesn't make a difference, or it doesn't make sense if you use the first condition or not. So you can remove the first condition and try, the result will be the same. So that's something I wanted you guys to try out, but I'm just stating that right now. Right. So let's give this a try over here, and let's see if we can figure out and solve this. Now, the moment we execute this, compile and execute this, let's give this a try. Let's see something like A, B, C, D, C, A, B. Now, it's supposed to be a lapindrome. Similarly, let's try A, B, or Z, A, A, P, and P, A, Z, A. It's a lapindrome. Now let's try one more thing called pizza. We know a pizza is not a lapindrome. It's just a food. Now, what's the output here? The problem is we're supposed to use J here, because we are doing the same character. We are increasing and decreasing the same character. It doesn't make sense, right? So we need to look at all these little things. So let's observe now. Let's give pizza for first case. It's not a lapindrome. Now let's give the second output as pizza and Z Z A I P. This is supposed to be a lapindrome and it works perfectly. We'll also try for odd characters just in case. It's a lapindrome. We'll try odd characters, which is not a lapindrome again. It's not a lapindrome. So our program works perfectly. This is our most efficient program to ensure that you can figure out whether a string is lapindrome or not within time complexity of big O of. Remember, the time complexity of this is big O of n by 2 plus 26. That's it. So it's in C++ at Believer. So this is exactly what we have done. So just remember, this little program here goes through only two conditions. It's constant. It's just one condition basically. It's big of 1. So we don't have to take that constant generally. And when we consider this one for loop, it goes through n by 2 times. Then this for loop, which goes to 26 times. So when the string is small, then you can say it's something like n by 2 plus 27. But as string gets larger and larger, this really doesn't matter. So we don't generally consider constants. We'll just end up saying it's big of n by 2 nearly. But to be precise, this is what it is. So with this code, shall we now go ahead and see if we can convert this into Java? What do you guys think? We have enough time to try this out. Let's see if we can possibly convert this into Java, because a lot of us may not always use C. A lot of us may also use Java in real life to go through competitive coding, because whether you go for C or C++ or Java, in both of these languages, you do have all the particular options. When I say all the particular options, you have standard template libraries in C++ to use, or to ensure that you can let's say have your own implementation of all sort of data structures, whether it is set, map, dictionary, or anything. For C++ you have standard template library. For Java you have collections, and for Python you have all the data structures inbuilt. So we can use any one of these. So let's try to convert this into Java. Yeah, I have one question. Can we do in Python? Yes, we will. So we have 3 files for that purpose: C++, and then Java, and then Python. So each one of the code we're going to convert over like this. So let's go ahead with Java. Now, here's what I'm going to do very, very quickly. Now, first thing here is I need the same variable. So we're not going to spend too much time, because we have already done the code. We don't have to worry much. We just have to read the string, send the string to palindrome function, and perform this. So I'm just going to copy the same thing. I'm just going to paste it here. But the only difference here is, in Java, please remember, string is a class which starts with uppercase S. Right? And we can't use cin to read the string. We need to use scanner. We need to create an object of scanner. So let's create object of scanner. Scanner sc equals new scanner of system.in. Now, once we have done this, we just need to read that particular value using scanner. Let's quickly do this without any delay. So here we have sc dot next line. Whatever we read the next line, we're going to store it in string, and we're going to send it to LAPINDROME function. Now, if you're sending it to LAPINDROME function, please note we are not creating an object of the class to call its method. Since we are not creating an object of this class to call its method must be static. So we're going to use static void or static int lapindrome of, we'll take a string str. So that's exactly what we have done. So let's read the string over here and let's try to work through. Now remember, first thing, we need to create an integer array of 26 characters. So first let's do all these that we have here. We're going to try to convert the same code. So remember, it's not a difficult task. Java is basically built on top of C++. We can use most of the code very similarly, unlike Python, because when it comes to Python, we cannot do the same scenario. So that's one thing which we just need to know and remember and work through. Now here, in this case, we have a couple of variables I and j, and we are using string dot length. Now remember, when we use a string, I have one question, static on that. Yes, it's exactly static method as we pointed out. So when we use string over here, let's say when we access length of it, the function is same. We can use the same function here also. But when we create an array, we cannot create an array like we did in C++. We need to create an array in a different way. So can you guys think of ways on how to make sure that all array values are 0? Let's take a look at this. Now before that, I'll just create the array over here very quickly. We're going to create a one-dimensional array is equal to a new int of 26. Again, remember, you don't necessarily need to use a loop. You can use a function called fill. Many of you may not be familiar with this, but if you want to know about this, there's a function called fill within arrays in Java. So you have to go through its own class. First thing you need to do is go through the class of arrays and use, let's say, the method. So if you want to use the method called fill within array, you need to first import it generally. So we have it in java.util.arrays. So since we are using multiple things, I'm just going to use star directly, so to avoid all of that. So we have arrays fill function. Just remember, arrays fill is the same thing as internally calling the same value. So there's no difference here. I just need to use arrays dot fill of our array name, comma 0. This will make sure that our entire array is filled with the value 0. So that's exactly what's going to happen here. Then after that, if the length of string is 0 or 1, we're going to return n as it is. Now, just to recall, just to make sure that you guys know this, whether you use this method or whether you internally or externally use a for loop, like for I equals 0, I less than 26, I plus plus, and initially assign every value to 0, both are the same thing. Both do the exact same task. It really doesn't make much of a difference. One just does it by calling a function internally, the other you're just doing right here. It's the same thing. All right, so let's go ahead here. We're doing the same thing, same exact values, same exact functions. Everything else is the same. There should be no difference. Now let's see if it is right. Let's see if it works as expected, because there's not much other differences that we need to work through. But remember, the moment you compile it, you're going to get a lot of errors. Sorry guys, this is Java, C space code.java. The moment you compile, you're going to get a lot of errors here, even though it's not as expected like that. Because in Java, there are few differences when it comes down to this. It expects a lot of different scenarios. I have missed probably one semicolon here, or equals. Let's update this. Now here, the lot of errors that you're gonna get is this comma operator within for loop. Now this is first scenario of the error. This is the first part of the error. There's more errors we'll get once we solve this. So let's try to see how we can use comma operator in Java when it comes down to for loop, because we have this in C++, right? So it should be we should be able to use this over here. Now let's take a look at this. What exactly happened here? In our case, when we tried this out, it says something called semicolon expected everywhere here. It says this sort of code cannot work. This sort of code literally cannot work. So let's see how exactly we can solve this so that we can make sure that we have an entire comma operator usable within, let's say, something like for loop. So this will keep it for our next scenario. This will keep it for our next part right now. But before this, we have one more error that we need to solve, which I'll just point out to and explain. So before that, let me just remove one condition here. I'll just remove one of the condition. Don't worry. Rest all remains the same. Only one condition is what I've removed. Now the moment I compile, that error is no longer there. This is because in Java, only one condition can be specified. This is the difference between Java and C++. Not in every case the same thing works. So these are some things that we should be familiar with. So in Java, there's only one condition that you can put. You can't use comma operators to put multiple conditions. In C++ you can, but it doesn't make sense because only last condition is counted. So since only last condition is counted, Java doesn't allow you to use multiple conditions whatsoever because only last one is counted. And followed by this, we cannot use index here. So one thing, we can't use index here, and we can't use again printf. So since we can't use index, let's see how exactly we're gonna solve, how exactly we're gonna sort this. First, let's solve this. There's no concept of index because string is an object of a class. To get index, you need to use its own function, that is dot char at index. This is how you get a value within a certain index in Java. So even here I need to use char at of j. And let's update this printf to system.out.println. Let's do the same thing here, system.out.println. And our function here is supposed to return an integer, which we are returning over here. That's exactly we are sending over here. We're going to see if it is 1, we're just going to do this. Otherwise, we're going to do as expected. Go ahead there. So let's see if it works. Let's compile this. Let's see if we get any particular errors. Now there are no errors whatsoever. Let's execute this. And we'll just give some values as before. So this is a LAPINDROME. Let's try one more thing. This is also a LAPINDROME. Let's try pizza. It's not a LAPINDROME. So our program works in every scenario, and we still are able to do this in big O of n by 2 plus 26. Of course, there's one more scenario here where there's one more 26 added here. So it's basically big O of n by 2 plus 52 instead. But that's basically constant. We need to initialize in prior. If we change it to fill function, it becomes just one line, but internally it's still doing the same, which we don't count. So there's all these gray areas that come up to this. So this is your Java program to do the same. Now, with this, can I give you guys a very small assignment? Shall we try this out? Probably by tomorrow's session, because we're gonna have one more live session tomorrow where we're gonna go through more programs. We have a particular program that has been asked in prior, which deals with the T9 keyboard, phone numbers, and everything like that. So a lot of these things are asked where you're gonna have to figure out what a person has typed and everything. We're gonna do these programs. But before that, what do you guys say? Shall I give you guys a little challenge for tonight? A little teaser. I hope you guys can think through and plan through this, try through this. Yes, right. So here's the little challenge that I want to give you guys. Take this Java program, convert it to Python by using the same time complexity. Let it not be big of n, let it not be big of n, let it be big of n by 2 itself. So let's see how many of you can do this, how many of you will be able to try it out. So I'll just give you a clue. Since there's no comma operator in Python, you need to use while instead of for. That's it. That is your simple clue. For you, since there's no comma operator within for loop, the way you can use, because for loop works with a range which is very different in let's say Python, you can use while loop instead of for loop and try this out. So that's your little challenge for tonight. So do give it a try. Challenge for tonight: convert the above code with same time complexity to Java. That's it. Sorry, to Python. So with this, we'll just share this content to you guys, and we'll end today's session. And I just want to point out, the moment we convert it to Python tomorrow, we have a very unique problem that is based on T9 keyboard, which has been asked a lot of times when it comes down to, let's say, interviews, which has been asked a lot of times when it comes down to interviews. And I do expect such questions to be asked, especially when it comes down to TCS Digital. So we're gonna do that program up next as well. So do ensure to join for the next session as well. So by the time, I'll just share the link for this particular content in the, we'll just share it in the chat so you guys can access it very quickly. So with this, I hope you guys had a really fun time going through this particular program. I hope you guys had a fun time learning something new, and I hope this was a session which helped you understand what sort of programs can be asked, how to get better time complexity in the programs, how to make sure that your program is better than other programs, and ensure that you can clear the interviews by ensuring whatever program is asked, you can do that by checking all test cases and by figuring out the least time complexity possible for programs. So do ensure to work in these way. Do ensure to always try to work through to make sure that you have the least time complexity and the least amount of memory used as well. So with this, I have one question. Will it be in the portal? It's gonna be in the YouTube. In YouTube, you can access it any point of, at any point of time through this. You have this whole digital playlist that's gonna be coming on a constant basis, which you can access. So with this, we'll end our session today. So do catch up tomorrow in our live session, where we'll continue with more programs, and I will keep looking at the live chat to ensure that I'll be able to answer your questions in this interactive YouTube session that we're going to have tomorrow the same time at 9:30. And we'll catch up in the next session. Thank you guys. Have a good time.